Hello, everyone. Welcome to today's show. And if you are joining for the first time, this is part of our digital transformation series, for which we meet every Thursday at 5:30 p.m. Eastern. We pick one topic related to digital transformation, and we always have an expert panel that is willing to share their insights and wisdom. For today, we have a very deep and complex topic, and I don't know how many companies really understand or do it right. So we are going to have a lot of fun discussing that. Before we do that, we are going to start with everybody's intros. I am going to start with my intro. If you don't know me, I am Sam Gupta. I'm principal at Elevate IQ. Elevate IQ is the independent ERP and digital transformation consulting firm. I've been doing ERP implementations for like 20 years now, and co-products, byproducts are always very religious topics to discuss. So we are going to have a lot of fun there. Now I'm going to move to Chris for his intro.
Thank you, Sam. Chris Gherardini, I'm president and owner of Turnkey Technologies. We're a 28-year-old practice that implements Microsoft Dynamics, ERP, and CRM. Good topic. Look forward to being here.
Thank you so much for being here, Chris. David, can I ask you to introduce yourself next?
Yep, excited to be here today, Sam. My name is David Dozer. I'm the president at Blaze IT. We're a reseller and implementer of cloud ERP solutions, specifically in the manufacturing space. So it should be a really fun discussion today for sure.
Okay, amazing. Thank you so much for being here, David. Mark, can I ask you to introduce yourself next?
Absolutely. Good afternoon, Sam. Thanks for having me. I'm Mark Lilly, president and CEO of LillyWorks. We help manufacturers solve the late problem by implementing a dynamic production methodology as opposed to the more traditional scheduling methodologies you find in typical ERPs today. Very happy to be here to talk about co-products.
Okay, amazing. Thank you so much for being here, Mark. Abu, can I ask you to introduce yourself next?
Absolutely. So my name's Abu. I'm the president here at Penny. We are Sage X3 reseller, and we have been implementing Sage X3 in manufacturing industry for the last 10, 12 years.
Thank you so much for being here, Abu. Now, if you're in the audience and joining for the first time, make sure you post your questions and comments. We typically try to cover during the show. If we cannot get to them during the show, then our panelists are going to make sure that you receive your answers. On that note, I am going to start with the first question with Chris. And that is going to be, Chris, let's say if people are not really familiar with what co-products and byproducts are, I don't know if you are going to have any sort of examples that you might be able to paint and overall talk to us about, from the BOM structuring perspective, what are going to be the implications, let's say, if we don't configure the co-products and byproducts right and don't really replicate the manufacturing process as they should be replicated.
Sure. Thanks, Sam. So let's start with just definition, not out of Webster, but out of me. But if you think about when you manufacture and you're consuming raw materials, and most people think in manufacturing is they have one finished good that comes out, but that's not always true. So it may not be a finished good, but the example I would use is I have a client that was cutting sheets of plastic, 4 by 8 foot sheets, and they're cutting parts out. Well, guess what? They have remnants. Oh, remnants. Is a remnant a byproduct? Well, if it has a value, it is. And if it's reusable, it is. And I said, if you think about scrap goes into trash, but sometimes even scrap is somebody else's byproduct, right? All your metal filings and shavings that go into a 50-gallon drum, somebody's taking those and doing something with them. So if you think about in your world and in the company, the plastic example where they're cutting the sheet, they use 2/3 of the sheet. In the manufacturing process, did they cost the entire sheet to manufacturing? And so one of the problems is that third of a sheet, it's not at zero cost. And so, then now we get into the weaknesses or capabilities of different ERP systems that allow you to articulate byproducts. Is it scrap? Again, scrap is one thing. I have a client that manufactures glass and they have a 250% efficiency rate, which means it takes 2.5 pounds of glass to make a pound of glass. Well, all this leftover glass, they're not melting that down. But to that point, the example with the sheets of plastic, they use 2/3 of the sheet. Again, the BOM is costing a full sheet It's not accurate. More sophisticated ERP systems would let you articulate the finished good coming out and then have a secondary output, which is a byproduct. And again, the weaker MRPs, what happens? Okay, great. They consumed an entire sheet of plastic. Well, that's not what happened. I've got a third of a sheet. What am I going to do with this? That's where the manual process start having to kick in, where, okay, do I take the third of the sheet and go lay it over in the corner of the warehouse? That's what a lot of people do. And they go, oh, let's go see if we got anything we can use. It's not in the system. It's off the books. It has value, no cost on it. So think about distortion. What did it take to make this part? Well, it's wrong because you used a whole sheet of plastic. What did it take to make this part? Well, it's wrong because you assumed the material was free. So again, a byproduct, if it consumes 2/3 of the sheet, an offshoot is a third of a sheet. It goes into a different product. You know, you got inventory that may have a unit of measure of feet, square feet. Well, great. You got smaller, but again, it may end up in a different product. It carries a cost. Moreover, the cost on the bill of materials reflected accurately of the actual material that's consumed. So, I mean, the sheets of plastic is a perfect example of a byproduct, and an injection molding is another one. I like plastics because they can recycle the remnants, the byproducts more easily. But even in the injection molding world where, you know, they got, you know, they're cleaning these things off. There's lots of shavings. There's extras, there's damaged product. It all goes back into the hopper, ground up, repelletized, reused. So there's an example of another byproduct. So, and again, I could go on and on. Plastics is the one I picked, but those are a couple good examples. But again, in the more sophisticated platforms, they'll drive that byproduct transaction into an inventory receipt that drops back into the system. Don't have to do anything. They're going to have the correct cost reflected on your BOM and that finished good you produced. Systems that don't have a byproduct capability, what are you doing? Somebody's over there with a sheet trying to capture it, and there's a business decision on, do we put them back in inventory? Do we put them back in a cost? How do I affect the cost of the BOM that's now overcosted? And you're thinking a lot of manual entries. That's why a lot of people put them in the corner of the warehouse and just don't do this properly. So a lot more I could say.
Very interesting insights. So obviously you spoke a lot about the byproducts, and byproducts also could have their own layers in terms of how they are defined. But we have another concept called co-products. So in your experience, the co-products and byproducts, are they going to be treated similar in the ERP systems that you worked in, or are there any differences between co-products and byproducts?
I guess I should have looked at the differences in the definition of a co and a byproduct. So I may defer on that one. So I don't know the answer. Sorry.
Okay, no problem at all. And I'm actually going to come to David, and I don't know, David, do you want to start with the differences? I don't know if you're going to be familiar with that. In every ERP system could be different, so it's very some people might not even treat them as different. So do you want to touch on what is the difference?
Yeah, I think that's a good point, and it's kind of, a lot of times it is a very gray area, especially when you get into how the ERP system is treating it. So I'm gonna steal from Chris there, and it may not be the Wikipedia definition, but it's going to be the Dave Dozer definition of the two. The way I kind of generally approach it or look at it is, it may not really even have that much of a transactional difference, but a co-product is going to be more you're sharing raw materials, or even a process or work centers to generate two products at the end of the production cycle. Whereas I kind of see the byproduct as more of, I kind of had a plastic example already staged up. So Chris beat me to that as well. But, that might be shavings or something that still has a value. You could still potentially even sell or use in another manufacturing process, but it's just kind of a offshoot, or almost to the point of scrap that's left over that you can still do something with, as opposed to the byproduct or co-product. The co-product or joint product gets a little more complicated in the sense that you may even need to plan for that, and that might even be an actual sellable item, and that's something a lot of times too with a lot of ERP systems that may handle byproduct to some extent, but it gets really complex in the joint or co-products, especially when you get into the application of overhead and labor, and then how all of those pieces get costed out and distributed across both of the products there.
Yeah, go ahead, Chris. Do you have a comment?
David, you nailed the word. Planned, non-planned. Co-products are planned. Byproducts are not planned. So you nailed it. So that is really the differentiation. Thank you.
So I'll provide some more colors there overall in my experience. And typically, it's not going to be just the ERP treatment that is going to be relevant here. My understanding is that it has far more implications overall how you are going to be planning your manufacturing lines. Okay. And typically, that is going to be used by the operations manager. So typically, in my experience, co-products are probably going to have some sort of financial value. Sure, you could argue that. I think Chris mentioned that, even a scrap is probably going to have some financial value.
Correct.
But typically, when you are accounting for your main line, you don't really account for that cost. I mean, you might sell scrap for some financial value that might be later accounted. But when you are, moving the good through the pipe, at that time, it's going to be just one manufacturing process, and you are not really sort of creating a fork as part of your manufacturing process. Typically, in my experience, when you are designing the co-products, it's going to be, let's say, if you are doing some sort of packaging of the electrical equipments, some sort of plugs that you are trying to package, and you are doing one packaging as 3x6, one 4x2, something like that. And then you don't want to have two different production lines, or you don't want to receive it in the inventory because you want to keep this as part of the same production line, because there is going to be significant production efficiencies, the way operations managers like to design their production lines. So I think that's where the differentiation comes from. That's my understanding. David, do you have any follow-up comments there based on my commentary?
No, I think that's a great example of kind of differentiating between the two. And it does get really important when you're getting into that planning and production flow. And that's where a lot of times there's somewhat of a disconnect between the ERP system and what's happening in real life, especially when you're talking about those sort of co-product or, joint products and co-products, and with the packaging example, or even when you've got a cutter and you're trying to optimize the cuts that you're able to make on a piece of material as well. So it's hard to sometimes capture that real life in the ERP there, but I think that's a perfect example.
All right, amazing. Thank you so much, David, for that. So, Mark, I'm actually coming to you in terms of setting the stage. And obviously, your dad has written books about bombs. So, obviously, some of these concepts may have been introduced. I don't know, maybe in 60s, maybe 80s. I don't know when they were introduced. But obviously, the manufacturing has become very complex lately. So, I'm pretty sure these concepts came along maybe 10, 20 years back. So in your experience, if you have any sort of history context, obviously provide that and paint a color in terms of what are byproducts and co-products and why they are relevant.
Sure. Yeah, you're right. I mean, in terms of ERP systems, some handle certain situations, others don't. And it kind of gets down to a level of granularity with what flexibility can you truly define your bill of material and your routing, right? And to get how are they operating together when you're planning to actually build something, right? Whether it's in the work order context or a standard BOM routing type of situation. So if you imagine, let's imagine just simple like 4 operation step, right? So say 4, I'll pick a shape, 4 squares that are the operation steps, right? So you start with an say one material, maybe there are multiple materials, but one material coming into that first operation. And then something happens to it, and then that material, value is added, the materials move to the next operation, so on and so forth. When you get to that last operation, you have an out material, right? And typically there's one, as we've said, there's one out material that's received into inventory. But the co-products, right, are the ability to say, I've got N number of materials that I'm now receiving. Could be 2, could be 3, could be 10, whatever the case may be. Chris, I think of plastics too when I first think of co-products, because I think of a family mold, right? In injection molding, I've got this mold that's designed to produce, 5 different plastic parts that are totally and completely different, right? But they're all in the same mold. So I inject the plastic in, right? And, a few minutes later, pop, it opens up and 5 different parts come out. So that's in my mind, that's the classic type of, and then those are being received into inventory. But there could be, throughout that 4 operation step process, there could also be out material. So I've got an in material coming in at the beginning operation, and maybe any operation, other operations, certainly a final assembly, you may have 50 different materials coming in, right? Typically towards the end of the process. But in any way, any operation along the way, you may have, whether through its processing or like, from nesting, and you get material out, you've got an out material at that operation, and maybe it's planned scrap, right? It's going to come out, you're going to scrap it. Or maybe it's a co-product that has value in and of itself, and you're going to receive that into inventory and actually use it, maybe on another job, you sell it, whatever the case may be, right? The other point of flexibility in terms of the routing structure and the BOM structure, if you will, is, and I think what Chris was referring to in plastics is in plastic sheets, I think of metal sheets, and that's nesting, right? So the engineers have a series of parts they want to get out of a 4x8 sheet of steel, right? So there are nesting programs out there, right? That'll design the best, based on the different shapes you want to produce, the best use of that material, right? So that can often be expressed by a single operation, and then all the co-products, right? All the different shapes, all the different parts coming out of that. Now those parts could be for the same project or even the same job, if you will, right? The same customer requirement if it's make to order, or they could be completely different and all be received into inventory, and then who knows what's going to be done to them, right? So again, some may be sold, some may be sub-assemblies or what have you. But it's that flexibility to say, I'm going to take one material in, several sheets of 4x8 steel, and I'm going to punch out these parts from them. And what am I going to do next? So it could be, I'm going to receive them into inventory, but I could also diverge. And this is a concept we often see, convergence, where we're making sub-assemblies, like sub jobs, and they're coming into a main operation, oftentimes a welding operation as an example, a final assembly, and they're all coming into that converging operation. But we also have divergence now too, right? So nesting is a great example where I'm producing several different parts, and then they're diverging and having operation steps done to each individual of those materials. And maybe after those steps, they're received into inventory, but maybe they converge back up, right, into an assembly or something like that. So it's about the flexibility that your BOM and your routing allows you to describe, like David said, to really reflect how production is happening and how you want it to happen out in production.
Okay, so my listeners must be thinking there, see, it must be a jaw drop moment there, right? Because of the complexity that we can experience in the manufacturing environment. By the way, thank you so much for bringing all of those in. And when we were talking about co-products, we were thinking that, you are probably going to have just 2 finished products. But in your case, you are saying that there could be 5 finished product, there could be divergence, convergence, and then all of that come together as part of the same assembly line. Now, there is a lot of complexity right there. Okay. So do you want to paint a little bit more pictures in terms of how the BOM configuration is going to be? For example, let's say one of the examples that you mentioned that, if you are simply punching your steel sheet and you are creating 5 different types of material, the only raw material that you are going to get in the operation is going to be your sheet. And you are, just simply trying to punch it out, and maybe you are creating the 5 different products. So from the BOM configuration perspective, how are you going to designate which products are going to be output of the BOM? Where are you going to configure that, all of that in the ERP system? And how are your BOMs going to be structured when you think about the whole process of, this co-products, 5 co-products, and then finally, all of that convergence, divergence?
Right. So first off, it's, you could lay it out into a flat structure to say, here's my parent, and here's all the components or all the materials I'm going to need to produce that parent.
Yeah.
So yeah, you could do that. But really, in order to describe this, one of these scenarios, even the simplest scenario where you've just got 4 operation steps, but you have different material needs, maybe on different operations, right? So in that sense, they need to be together. Your routing and your bill of materials needs to be one engineering model, engineering master, it's been called. Okay, so it's not two separate things. It's one thing. So we're describing the processes and the materials that are required on each of those processes.
Okay, amazing insights there. Sorry, Mark, you still had some thoughts?
Yeah, well, I was going to say, and you're defining what materials are coming out of each of those processes, right? Whether it's at the last operation and their finished items coming out, or anywhere along those processes, something coming out, and again, whether it has value or not. And then we get into it, and then the whole other topic is costing, right? How do you cost that? And the simple, the simple example or area, I should say, is those finished items, right? And I say it's simple only because, how do you cost a material that's coming out halfway through an entire process of 10, 20 operations, right? But on the final end, let's say you're producing 5 different parts, and maybe it's even different, different quantities of different parts, right? So how do you spread the cost of that entire, all the materials that went into it, all the processes that went into it across those? We've seen it different ways, right? Some are kind of loose about it, and you just say, you list the part numbers that you're going to be receiving as co-products, and you put a percentage in. Maybe you can split out the material, labor, and overhead cost percentages for each of the parts, right? And that would ultimately obviously has to add up to 100%. But then otherwise you could you could have it split it equally or do different things with the quantities. So there are different ways to cost it in the end too. But and it obviously, if it's standard costing, then that's the easy approach. It gets more difficult if you're trying to cost those parts on an actual cost basis. That's where it gets a little tricky.
Okay, very interesting. So we are definitely going to have much deeper discussion on costing, because I think co-products and byproducts get really interesting when you are trying to cost, and especially if you are going to have such complex layers the way you had described. And it gets really deep, to be honest, when you are working in the complex manufacturing environment. Thank you so much, Mark, for that. So, Abu, I'm actually coming to you. And in your experience, do you agree with the definition? Have you seen any other differences overall in terms of the context when you think about co-product, byproduct? I know, especially when you talk about agriculture industry, food industry, that's where the co-product and byproducts are going to be super relevant. So I'm pretty sure you are going to have a lot of examples there as well.
Yeah, I mean, generally, I agree with all the presenters have spoken so far. I mean, so core products would tend to be, as David was saying, planned products. Another layer you could probably add on to is core products. You want to cost them back into the inventory. Byproducts, you don't necessarily have to cost them, right? Or you can say they're not going to be significant compared to the end product. Examples of core product, one example which probably everyone can understand easily is, you're taking crude oil and you're distilling to make kerosene, different fuel, diesel, right? So that would be a core product example. Any distillate left which you cannot refine further becomes a byproduct. Sometimes even that is sold off for the plastic industry to be used. In the food industry, for example, you're willing wheat, and then you have a byproduct called a bran, which you can sell as an additional product. So I mean, so byproducts can have value. It's not the main product that it's not intending to manufacture. Generally, you would have a cost which is significantly less compared to your end product. Almost financially irrelevant, I would say, compared to the end product. Core products, you're going ahead, you're going to make them, and you're going to sell them or use them further along the process. One example, from a byproduct perspective that I've seen, which is complicated, is especially in the cannabis and the agriculture, they're using solvents, for example, for extraction purpose. You use a solvent in a process, now you can get that solvent back, refine it a little bit, and then reuse it in the next process, right? So is that a byproduct now, or it's you've already taken that into cost? So now when you're going to use in the next product, how do you cost it, right? So so different nuances, variations in the industry regarding core products and byproducts.
Okay, so very interesting insights there, and I don't know if you chose the example about the crude oil, purposely, or I don't know if you have sort of any experience working there, but that could actually add another complex layer if you think about it, because that's my understanding of that environment is going to be that is probably going to be slightly more continuous manufacturing, and then you have to account for that as well. So the costing is going to be far more difficult if you really think about it. Even in some batches of plastic, I would say there could be continuous manufacturing. So then, it's never ending process. So I don't know where you sort of call the full stop that, okay, now this is going to be your full stop. And, we are going to account until this point, and after that, we are going to consider it as the next process.
Yeah,
So
I mean, by batches generally, I mean, in the chemical space, you'll have batches, you'll refine it, you'll take an input lot, and then that's how most companies would do it. It's just a larger amount of batch. It can run over several days, for example. But by lots or by batches is how most companies would do it.
Okay.
Define endpoint.
Amazing. Thank you so much, Abu, for that. So, Chris, I'm actually coming to you, and we are now discussing the costing. What challenges have you seen overall from the costing perspective when the byproducts or the co-products are not going to be accounted the way they should have been? And then what are going to be the implications?
So on the ones where it's planned, and I'm actually working on a project now where the equipment manufacturing for nesting and the feed, and so what there's going to be a pretty complex the data that the machine collects on the nesting, so that as it passes that back to the ERP, it really passes the precise material cost. And then if you look at the total usage of the equipment, fractionalizes that based on the nesting. So that's getting pretty sophisticated, because we're taking a standard ERP, and the machine manufacturer actually added a module that takes the nesting data and articulates all the costing. So that's going to get pretty precise for this company that's grinding out aircraft widgets. Again, on the other side, the part where it's challenging is where they're byproducts that you really have some value to them and you didn't plan them, right? And you're like, so I think it goes back to, if you plan them, they're going to be costed correctly, because the system's going to know what the math is on what fraction of the sheet goes to A, B, and so forth, just like the nesting equation. But as you get into byproducts that are usable, again, how do you come back and adjust the cost of that finished good that you just produced, because it only used 2/3 of that material? I mean, it gets really manual and tedious. And I think depending on the value of the byproducts, the question is, are they managing it online, or are they keeping it off the books? I've seen both examples. The ones that manage it online, right, they're categorizing it into different usable pools. But the other challenge there is, how do you construct your BOM so that it knows, well, look here first and see if there's any usable byproduct before it rolls over to what we know are whole sheets. And so now you've got yet another manual process where someone's got to go see if you've got anything big enough, unless you really segment the inventory. The same thing. The BOMs are pointing at whole sheets. It gets real kludgy. Or you have to tear down your inventory so that your building block in it is, we're tracking it in square feet, even though it's 4x8 sheets. But then you never know, well, how many 4x8 sheets do I have versus square feet? So it's not a perfect answer. I mean, and again, in the weaker systems that don't let you define a co-product, you've got a lot of manual process. And I guess it comes back to the materials. What's the value of the material? We got another client that's grinding body parts out of a tube of composite. Okay, it's $10,000 an inch. Okay, they're really concerned about that, versus if it's a $3 piece of plastic, you get it. So the value of these products and the materials they're using are really going to change your measure of emphasis, frankly, right? Because 80-20 rule. Like I said, you don't want to be dealing with minutia here. So
yeah, completely agree. And by the way, MEC, overall, from the conversation so far, I'm actually surprised that nobody has really touched on the yield aspect of the things. And typically, in my experience, co-products and byproducts are going to be discovered during the yield analysis. So here is how the process goes typically in my experience. Okay, you are actually inputting, let's say, 5,000 pounds of meat, and you are expecting that, okay, these many sausages I'm actually trying to get out of my process. Okay, you weigh beforehand, you weigh after the fact, and then your assumption is going to be that, okay, if I'm inputting my 5,000 pounds of meat, then I expect 5,000 pounds of sausage. So now you are trying to figure out what the hell happened. Okay, so then you are going to get a guy who's going to be on the shop floor, and he's going to tell you, oh yeah, I know, we get this random meat here that we typically try to sell to my community members, and then we are going to figure out, okay, what is the cost of that? I sell like $2 a pound. So where does that money go? So there is whole conversation about that, and that's where these co-products and byproducts are going to be discovered in the manufacturing process, in my experience. Chris, so I don't know if you have seen anything similar. If you
I've
have any
got the
follow-up
salami
comments.
guy. The salami manufacturer's the client, and you put a 1,500 pounds of meat in, you don't get a 1,500 pounds of salami necessarily, because there's some shrinkage and
I
there's
know,
some
I
other
know.
things. But you're absolutely right about that yield analysis. And again, there's a lot of stuff that's fallen off the edge of the table that's sold off the back door. There's some of that going on, but those are cash transactions. But generally, from input weight to output weight in yield analysis, I don't know how much they're doing in the sausage place. I mean, I really don't. The glass guys, the guys that I said that are extruding glass and they have a
Yeah.
250% inefficient. I mean, again, they break a lot of stuff trying to make the very, very precise stuff that goes into IV bottles. So again, extruding glass, and they measure their efficiency tremendously because it impacts their standard costing, right? So that's the other thing it cycles in. If you're doing real costing versus standard costing, okay, where do you start seeing the variances, right? We didn't even throw that one in there. So standard costing, you really need to do yield analysis to figure out, are my standards too high, are they too low? And if they're based on a 250% efficiency, okay, and if you're hitting 125, that's a major difference in consumption of raw materials to output. So to that point, you're right. Yield analysis as you're getting into your standards, and again, as you look at meats and the sausage guys, I think they're doing pretty good because they've been making salamis for about 100 years now, I think. But anyway, it's a good comment.
Okay, amazing insights there. Thank you so much, Chris, for that. So, Dave, I'm actually going to come to you, and we are discussing the costing. Any deeper insights that you might be able to provide overall from the costing perspective and the challenges that you have seen?
Well, kind of building some on what Chris already laid out there, I think one of the biggest challenges, or at least kind of the way folks handle it, comes down to the dollars that are really involved and how nominal that is. I mean, like we work with one plastic manufacturer and we got little shavings left over at the end, and that just goes to scrap essentially, and it goes into a big bucket. And then, once a month, recycler comes by and they get magic money for that recyclable material. So that's not being tracked. It's just sitting there in a big bin in the warehouse, and then make a little bit of money off of that. But on the flip side of that, we work with a food manufacturer in the extract business, and so they have some byproducts from that extraction process that they can sell that have nothing to do with extracts, but they can sell to other food manufacturers that are used in their processes. So they're a lot more stringent, with tracking those byproducts as they're coming off, because it's a real sellable product that they can sell, kind of in the Wheaton brand example as well that Abu had laid out there. So a lot of times it comes down to the dollar value associated with those byproducts and how closely they're tracked. And tying it back to the ERP side as well, there's still a big problem that you see with a lot of folks is they're kind of haphazardly tracking that, in a lot of ways. It's just getting absorbed into the material cost of the main product. And maybe they'll do a count, maybe they're keeping track of it in a specific GL, and then they're going to do a cost allocation to get that out. But it's one area that a lot of even very advanced manufacturers we've worked with can, I don't want to say struggle, but could certainly improve the costing when we're dealing with these sort of scenarios.
Okay, very interesting insight. So now, Dave, I'm actually going to give you a trick question. Okay.
Uh-oh.
And the trick question is going to be, okay, when you look at the co-products and byproducts, okay, so one of the drivers that we all are agreeing that, especially when you look at the co-products, the driver is probably going to be the financial value. If the product is going to have some sort of financial value and that's going to be part of your production line, then probably it's going to be a co-product, right?
Exactly.
So now, let's say if the co-product that you are getting out of your manufacturing process is more expensive than the main product, okay? If that is the case, would you treat this as the main product which has higher financial value, or would you?
Well, that might be a trick question. Personally, then, I mean, maybe you need to evaluate if you're in the right business, and if you should be selling a different type of product line. But and I'm going to stick to my guns on the financial implication of it.
Yeah.
And I think it would kind of require an evaluation then, and say, okay, well, if we've got this byproduct or or co-product that's coming off of this line, and this has a higher value than what we're originally intending to produce from a sales perspective, then probably that should kind of become the main the main product, really, at least in my opinion. And now in that example, joking aside, most likely that's one where you really need to get the process in place, obviously, to track both of those appropriately based on the BOM and how you're handling your jobs and your shop orders with that. But so what's the trick answer to that then?
I don't know. We lost Mark.
All right, I'm curious to hear that one.
Well, you're discriminating, right? I mean, why is one product the main product and any other, something you just call a co-product not, right? I mean, Well, I think the differentiator in our minds is the fact that, when we're using systems, for example, there's typically one product and that's the main product. And oh yeah, it supports co-products. So here's the other products. But really, what's the difference, right? I mean, you have a job, you get a work order that's producing, multiple end items. What makes one the main one versus not, right?
But from the system design perspective, so I'm actually going to push you back a little bit there, Mark. Okay. So from the system design perspective, I mean, when you are releasing your job order, you are going to be specifying one item. And typically that is considered to be the main product, right? Because that's what is being released as for the job. And there are going to be some sub-products that are going to be part of your production process. So system is what is discriminating. It's not us. Okay, that's how most ERP systems are designed. So you can't really say, okay, here is my BOM. Okay, I'm looking for 5 product 1, 2 product 2. That's not how manufacturing process works. In my experience, at least, I don't know if anybody's going to create a system that is going to give you an ability the way you create your sales BOM. Okay, your manufacturing BOM, releasing the product, your sort of the order for the production floor. Here is the complex BOM that you can probably release on the production floor, and you are going to get all of these products. Then everything will become main product. But that is typically not how the production orders are released, as far as my experience goes.
I understand what you're saying, and look, I'm not saying outside of a complex BOM, right? Even just the simplest, like an injection molding machine, that's typically one operation, right? But I'm producing 5 parts. Why is one of those parts in a family mold, for example? Why is one of those parts called the main part and the others are the co-products? I'm making 5 parts. They're pretty much equal. Now the costing may be different because of, and there we get into the costing conversation about how much material is one using versus another, right? What do you do with the labor? Well, probably do you allocate the labor based on how much material was used, or we just cut it down the middle and make it equal, right? And now, all right, now you want to have a conversation, bring up overhead, right? How are you going to allocate the overhead across those 5 parts, right? Are you going to make it a percentage of the material of the labor? Well, the labor is equal. And now are you going to take the overhead and apply an equal amount of overhead, right? How are we going to, so am I really going to take, if I'm making 5 parts, am I going to take 1/5 of what I would allocate to a main part and apply it to each one? Or am I going to fully allocate the whole overhead value to each of those 5 parts, right? And that's where things get interesting, almost philosophical.
Yeah, most certainly. And let's, Chris, you have a comment? Yeah, go ahead, please.
Yeah, I think it's interesting as you think about the primary product, because let's go back to the sheet of metal where you're nesting. It's not one BOM. I got 5 production orders that I'm making a single part on. Somebody else articulates that I can cut these out of a single sheet. The BOM does not articulate that I can combo these into a mold, nor does it on the injection molding world. So even in the injection molding world, it's not like you got one BOM that's making 5 parts. You got 5 BOMs, and somebody says, hey, there's an engineer or somebody that figures out how to build a mold where he can make 5 at the same time. You know what I mean? So I don't know that you get a single production order feeding an injection molding that's making 5 different parts. You may have 5 separate production orders and there's somebody else. And I don't think the ERPs are typically articulating how to compose a mold or a cutting, you know what I'm saying? Am I correct, Mark? That's normally leaves the ERP when that type of, and it's an individual or it's an algorithm, a machine that's taking this data, but it doesn't typically have in the ERP. And I don't see the BOMs constructed where it says, hey, I'm going to put 5 finished goods on this BOM because that's how the injection mold is going to be set up. I think they're independent. That's just my opinion. So
depends on the ERP. Yeah, there are ERPs that definitely support. I've got one BOM, and it's designed. The design of it is to produce 5 end items, whatever the case may be.
Yeah, so super interesting and deep discussion, and this is the discussion that I personally like, because this is where we get the details that listeners, should be getting. That manufacturing is really complex, and the costing is going to be even more complex. So, Mark, I want to touch a little bit more on the divergent and the convergent aspect of the configuration. So, let's say if somebody is trying to configure and find out the costing when you have the convergent and divergent process involved as part of your BOM, how would you configure that?
So the costing is the same, really. Whether and let's keep it simple again, right? The four operation steps. You've got an in material. Okay, so you've got a raw material cost. You've got the cost of doing the processing on each one of those operation steps. You're applying the labor, whether you're actual or standard. You're applying an overhead rate. So there's your cost. The fact that now, if you go a little more complex, where maybe I'm doing convergence, so where typically I might have 4 separate work orders, say a work order for the parent, and then 3 sub-assembly work orders that are coming together. Yes, a lot of systems, you need to receive each one of those sub-assemblies into inventory and then issue it back up to the parent. Many systems today support kind of the sub-job concept, where really those sub-jobs stay in WIP, and that costing flows up into the parent. So it's kind of natural that way. So same sort of thing, only now on the other side, you've got divergence, and with nesting being a great example. So to Chris's point, the nesting can be its own work order, right? Because I know I've got to produce these 5 parts out of this one sheet of aluminum or steel, right? And they're going to go into inventory and then be issued up to their parents. Or if it's one work order, you can have that divergence where you've got the nesting, and then you've got picture like 5 arrows coming out of the first operation, and then going into whatever operations need to happen with those, whether it's just one or multiple or what have you. And then at the end of those series of operations, in each of those diverging parts, those can be received into inventory as an item, or if it's a complex build, it can converge back up into other operations to get to finally a single part or multiple parts at the end. So the costing is all the same. It's simply the way you're describing the material flow through production, right? Is really where you use the convergence and divergence. But the costing is all the same. You get your processes, the cost of those processes, and the cost of the in materials all along the way.
Okay, amazing insights there. Thank you so much, Mark, for that. So, Abu, I'm actually coming to you. And anything you have seen from the costing perspective, any layers, the way they should be accounted, any sort of insights related to costing?
Just going back to one of the conversations, right? So you're talking about grinding examples, losing meat. I've seen in the food industry, you're grinding nuts, for example, and you're losing nuts, right? And we're talking about yields. Generally, that will be treated as scrap, right? So I would add an additional layer. If you are measuring something, it will be a byproduct. If you're not measuring, it will probably be a scrap, and you're doing a yield analysis on it. And if you're costing something, then depending on cost rate percentage relevant to your industry, to your business, and your overall product, either a core product or a byproduct, right? And you add that planning layer on it. Generally, in the food industry, it's the decision is generally basically based on the overall relevance to your business model, right?
Yeah.
That's how I would say it's costed. A lot of industry would do a simple costing mechanism. You're getting raw material in, what's the percentage out, right? Based on the overall costing. They'll do that percentage or the proportional in the chemical and the food world to calculate those byproducts. It's probably more difficult in the the discrete manufacturing, where you have nesting and all of that, where the proportionality is more harder and complicated to define. But generally, it's always a discussion, how to cost it, whether we should cost it, whether we should put on overheads on it or not. So again, depend on the business model, I would say, what you're operating in.
Okay, amazing. Thank you so much for those insights, Abu. So now we are going to do one more round, and this time we are going to be covering the scheduling as well as the testing. So if you look at the byproducts, I mean, they could actually follow different testing process as opposed to, again, if we are calling it as the main product. Okay, so if you have 5 products, they may have their own testing requirements, and then you have to specify how the testing is going to work. So, Chris, I am actually coming to you. And let's say if you look at the scheduling, obviously scheduling is going to be far more complex, especially when we think about scenarios such as what Mark described, in terms of the kind of, assembly you might have overall in your co-products, the way they are nested together. That could be very complex. So scheduling as well as testing is what I'm looking for, Chris.
Sure, and I think back to the example where Mark's got a BOM that has 5 co-products, and maybe I have 5 BOMs that have 5 products that somebody's putting together and nesting. And I think as you go back to rationalizing the routing times and things like that, I think they are fractionalized in that scenario. Whereas in Mark's scenario, the time is spread differently. But as you look at scheduling, if I've got independent products that I'm trying to produce and I'm trying to nest them, again, the scheduling does get complex there. But remember, what we said about byproducts is they're not planned, they're not tracked, which means a byproduct is not in the system. It's off the books. So, back to costing that and bringing it back into the system, it's going to require an inventory receiving. And then what? You're triggering a quality process. But the byproduct, in my opinion, is something that shows up and is not on the books, meaning the co-product is still in the system. Again, it could, whether we're diverging each of those co-products, primary products, whatever you call them, they could still trip a quality requirement in the next operation because they're in the system and they're flowing naturally. Whereas, again, in my opinion, the byproduct, it's off the book. They didn't plan it. What am I going to do if I'm going to put it into a quality or scheduling it? And I think that's the part that where if it's a byproduct, it's really, really needed, turn it into a co-product and plan it. I think that's what we're bringing out of this conversation as well here is that, if you're not going to plan it and it's not in the system, you're going to have a manual process, again, to pick it up, to count it, to inventory it, to receive it, to put some cost on it, and to decide, do you put it through a quality process before you put into on-hand inventory that you can reuse it? I'm sure it's no different than some of those tertiary products out of oil refinery is, who knows what's in there, but they probably have some stringent sampling before they put it into something that's going to be used in, household applications. But beyond that, again, I think that's it is the, if they're co-products, I think they're going to be scheduled as part of the standard features in the system, whereas byproducts, there's no planning there. So what you get is what you get. And then someone's going to have manual processes to surround those. So.
Okay, very interesting insights here. And Dave, I'm actually coming to you, and I am probably going to have the trick question again. And this time, you are not allowed to pass to Mark. Okay.
All right, I won't throw it over the fence.
Okay, so in this particular case, obviously now when we are talking about byproducts, we are thinking that, no financial value, nobody cares, it's pure garbage. Who's gonna worry about that, right? But if you actually talk to some of the procurement folks, and if you are talking about things like radioactive waste, okay, so sometimes the planning for the radioactive waste may be far more than your main products, okay? So that is going to go through the whole process again. So how would you handle let's say if your byproduct is going to have very complicated processes from the testing perspective, would you treat this as part of the main process? Would you treat this separately? How would you approach this?
I mean, when you get into that, and that kind of falls into the testing and QA type of question a little bit, and I'll echo what Chris said a little bit in the sense that, I think once there's any sort of additional requirements, at least in my personal definition of it, it's no longer really a byproduct. Like technically, yes, it might be a byproduct in the example of radioactive waste that we need to do something with, but from a system perspective and how we're handling that, as soon as there's a routing or a process that needs to take place with that, so whether it is doing some sort of testing, or even in this case, maybe we have to do some sort of scheduling for disposal, then I think that needs to be handled appropriately within the ERP, and whether that's, having your own a special routing set up for that. So it's going to get issued out, go into inventory, follow a specific routing process to handle that. Because the second you start doing all this stuff, trying to roll it in as part of the process or doing it externally, you're going to lose control over it. So, once there needs to be more than just some Wild West around it, then it becomes a product at that point, and whatever you do with it from there, that's based on the business requirement. But it's my 2 cents on it, at least, without throwing it over the fence to Mark.
Okay, amazing. Thank you so much, Dave, for that. And Mark, obviously now this is going to be your moment, because you were waiting for the scheduling question, right? And you are probably going to disagree with everybody, that because these guys are saying, co-products, byproducts, no worries, ERP, pick and schedule. But you are going to say, scheduling is probably going to be way harder, right?
Yeah. So let's start with the simple example, right? Just the four operation step example again. Really regardless whether the times, so there are times at your estimated setup and run times in each of the steps, right? In order to produce those end items. So there's really nothing really different to that routing from a scheduling standpoint if at the end you're producing just one end item or 5, right? 5 different parts, right? So now obviously that would be reflected in the routing. What we've struggled with, and look, our team has done scheduling for a long time, and what we've struggled with is in a typical backward. So if I try to backward schedule those 4 steps, I'm basically saying, let's plan to finish the last operation on the day it's due, maybe the day before, right? But typically on the day it's due, right? And backward schedule those. If I do that across for all my work orders, then I don't have a lot of leeway there, right? And how do you get a production manager nervous? I'm gonna release. I've got 16 hours of touch time across those 4 operations. I'm gonna release it 2 days in advance and expect those to get done in perfect sequence. Not if I have 500 jobs and work orders in the shop, right? So there needs to be some leeway there. On the other extreme is forward scheduling. And what often happens with forward scheduling is folks really don't know how far in advance to put it out there. So oftentimes what happens, it's as soon as we get material, or as soon as it comes out of engineering, just get it out into production. What happens then? Well, you flood WIP and everything just comes to a grinding halt. You get all sorts of bottlenecks. There's just so much out there. So there needs to be a balance point. So that's in the simple example. Now you bring into the picture the idea of convergence, right? So here's the hard part, right? So you've got multiple work orders typically that somebody's trying to manage in order to get those done for the parent that needs them. And that's just one level. What if you have two level BOM, 3 level, 4 level, 10 level BOM? You have multiple people in the organization whose job it is to manage those work order due dates to try to get those sub-assemblies done for when whatever parent needs them, et cetera, okay? So the point being, if you're using convergence, all you have to do is manage one date, because those convergence points control the dependencies, and then you can see, oh, here's my due date, here's when I'm going to need to start my top level, here's when I need to finish anything that's feeding it, here's when I need to start whichever ones are feeding it, and so on and so forth down the line. So you can visually see the whole structure and the dependencies, and the dates are managed for you. Now that's if you're doing a where you're truly building the sub-assemblies specifically for their parents, right? In many cases, you've got common sub-assemblies, right? So I'm making a separate work order for the sub-assembly 3 levels deep in the BOM, because it's not just feeding this work order or this parent part, it's feeding, 10 other different parent parts, right? So now you've got to do an allocation sequence where you're figuring out, when does this work order need to be done in order to feed the first parent that's going to need it, right? And that's that's another part of convergence that can help in scheduling and help alleviate the tedious manual, having to try to adjust due dates across all these levels. In the case of divergence, now it gets even more fun, right? So divergence is you've got a lot of different materials coming out, and they have their own processing times. So now it's more an idea of when will I be able to start whatever parent these are going to, or when will I finish these? Well, that's it. So you typically look at the longest leg, right? Whichever one coming out is going to have the longest processing time is gonna control ultimately how far back you need to start that initial nesting in order to feed the divergence, and whether those are going into inventory or ultimately a convergence back up and into a final assembly type of thing.
Could not agree more. Thank you so much for those details. Abu, I'm actually coming to you. So anything related to scheduling or testing?
So testing, it depends on the kind of industry. I mean, a lot of, if you're in a controlled industry and you're going to reuse that byproduct, for example, in your next manufacturing process. So for example, you have terpene oils in the cannabis world and you need to reuse it, then you have to do some testing before you can reuse it, right? So that's where it will come in. I mean, in my opinion, like, you can test a byproduct. It does, it depends on your business model. You don't have to cost it because you can reuse it a couple of times, right? So it's an initial cost. In terms of scheduling, I don't think you would be scheduling a byproduct, especially in the chemical and the food industry. It would be hard to do it. So most of the systems out there are based on scheduling the main bill of material, right? And then everything else is a byproduct or co-product which comes with it. One comment I would like to say is, I'm not sure if the pure definition of a byproduct is it cannot be inventoried. So I think it depends on the industry. I mean, a byproduct, in my opinion, would be something, which you don't really care about. For example, you're expecting 1 liter of byproduct. If you get 0.6, you're not going to go back and try to figure out why there's 40% less byproduct, for example, right? If it's a core product, then you'd probably want to go figure that out. So, I mean, the food industry, depending on your moisture content and your sugar refining, for example, you can have different content of molasses as output, right? But it's a byproduct. You're not going to go back and try to figure it out why it's less or why it's more. With core products, that would be, more of a case trying to track the yields around it. So,
okay, very interesting. Thank you so much, Abu, for that. So the only thing we can take right now is probably going to be closing advice. Chris, do you want to provide your closing advice?
Sure. So as you look at your operations and you look at byproducts or co-products, and I think first of all is, does your system have the capability to manage that for you? I think the other thing is, do the economic part of it, meaning, what's the value of the byproducts? The co-products, you're obviously planning those have value, but looking at the value of the byproducts and considering they're off book, look at the manual efforts necessary to manage those and just do a P&L on it. Is it worth it? Is it worth it to throw it away? You may have some byproducts. Okay, we're going to manage these because this is gold. You got other stuff, but just do the math on it is all I'm saying. So I think it's a good starting point.
Could not agree more. Thank you so much, Chris, for that. Dave, what would be your closing advice, please?
Yeah, I would definitely on the byproduct front kind of challenge folks, especially as they're getting more into manufacturing or doing something new product line, to look for those byproducts and those opportunities to turn that into dollars as opposed to taking it straight to scrap. Sometimes it's not always apparent because it's not part of your core your core business. So just, maybe an opportunity there. And then to the technical side of it, yeah, I've seen ERPs handle these situations in dramatically different ways, and some great, some not. So, it's something to think about too, as you're looking at systems and how to integrate and get the most out of your ERP.
Okay, amazing insights there. Thank you so much, David, for that. Mark, what would be your closing advice, please?
I'd say just, kind of outside of any systems, outside whether ERP or tools you're using today, just kind of, look at how production happens in your environment and kind of see, how best to reflect that. Maybe it is multiple and separate work orders. Maybe it's combined work orders with convergence or divergence, the co-products in particular. Just see what makes sense for you and go forward with that.
Could not agree more. Thank you so much for that advice, Mark. Abu, what would be your closing advice, please?
I mean, I'll agree with Chris and David. I mean, do an economic analysis. Is the accounting and the tracking effort worth it to keep track of all those byproducts and costing them? You may be in a controlled industry, so you may have to do it, but at the end of the day, you try to keep it as simple as possible. Overcomplicate it and you'll run into trouble.
All right, amazing. Thank you so much for that advice. So that's it for today. If you joined for the first time, this was part of our digital transformation series, for which we meet every Thursday at 5:30 p.m. Eastern. We pick one topic related to digital transformation. So make sure you guys are going to be here. We are going to come back with another topic and another panel. On that note, thanks everyone for your time and insights tonight.
Thanks, guys. Good
I
seeing you.
appreciate it. Take care.
Thanks
Thanks a
all.
lot.